Chapter 1.4, integers and absolute value. Take out your vocab sheet, please. In the center of that vocab sheet, will you write the word integers? And then you can also fill in the definition of an integer.
We did this last year.
If you are going to sit down with a toddler and you're going to count how many Cheerios are on their tray, or maybe you're going to count the number of cars you're playing with, what number do you start with? 1. What do we call those numbers? Like 1, 2, 3, 4, 5, 6, 7, 8. Not whole numbers.
Integers.
You are counting. They are called counting numbers. Another name for counting numbers are natural numbers. It is natural for you to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, you guys said whole numbers. There's one difference between counting numbers and whole numbers. What's that difference? Tina?
Whole numbers are natural numbers you start with, you're just counting. It's where you always start off when you're counting.
Okay. What about a whole number?
A whole number?
Addison?
Whole numbers you start with 0.
Whole numbers you start with 0. The only difference between a counting number and a whole number is the number 0. Once we go up from there, we go to an integer. Now, an integer, notice, says a whole number and their opposites. Look at the number line over here, please. In the middle of my number line is the number 0. Number 0 is separating the positives from the negatives, correct?
Mm-hmm.
So if I were to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that would be my whole numbers. Notice the definition of an integer says whole numbers and their opposites. So that would also include -1, -2, -3, -4, and I would continue. Notice what it says in the middle of our number line. Integers. This is an example of an integer number line. Do you see any fractions or decimals up here? No, because fractions and decimals are not included as integers. It is just whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and opposites, -1, -2, -3, -4. Get the idea? Let's talk about opposites for a second. Opposites are the same distance from 0 on the number line. So if I told you 5, what would be the opposite of 5 and still the same distance from 0 but on the other side? -5. What would be the opposite of a -23? A positive 23. They are opposites because they are both the same distance away from 0. Okay? But on opposite sides of 0. So, continuing up here, the definition of an integer we said is whole numbers and their opposites. Down to the very bottom down here, we have to put characteristics. There are no decimals, and there are no fractions. No decimals and no fractions. Examples. I need 5 examples of integers. Make sure that we have examples of both positive and negative integers when we're doing this. So, Carly, give me one. -5. Give me another example. Ellie. 7. Zane.
-16.
2 more. 2 more.
10.
10? Lucas? Seriously, she did not have 10. You weren't thinking 10 as well, were you?
No.
Okay. Oh, I'm sorry, Micah.
-15.
I should just say Mr. Fuller, and I'd be fine. -15? Sorry. You know, after having all of those brothers of yours, it's bound to happen, man. Just be glad I didn't call you Gracie.
I mean, it looks the same.
There you go. Gracie's cute. You wouldn't want me to call you cute anyway, right? You're handsome. There's a difference. On the other side, non-examples. What numbers could we have that are not integers? Justin.
1.34.
So 1 and 34 hundredths?
Yeah.
Okay. Taylor.
Is 0?
Okay. The definition said whole numbers and their opposites. Is 0 a whole number? Yes, it is. So it's also an integer. Okay? So any numbers that are counting numbers and are whole numbers are also integers. They just get 3 categories that they're in. So you want to give me a different one?
No, 5.9.
Okay, let's get away from decimals. Give me another one. We could have some negatives here too. Danelle.
4/20ths as a fraction.
Okay. How about one more? One more. Ethan.
5/20.
That was not very unique. 5/20, 4/20. What about the symbol pi?
That would work, yes.
Yeah, that would work.
For pi, we use that to find the area of a circle or the circumference of a circle, right? What number is pi?
3.14159.
And it goes on forever and ever and ever, right?
Two.
Well, then pi is not an integer. We actually call that an irrational number. What about something like the square root of 2? Can I think of any number that when multiplied by itself would give me exactly 2?
No.
There isn't one. I could do square root of 4, right? What's the square root of 4? 2. 2 times 2 is 4. But the square root of 2 doesn't have a number like that we can do that with. So those would be called irrational numbers as well. Questions on what an integer is? Okay, so we're going to go back into our notes page then. And our definition here says, write an integer for each situation. So if I lose $7, what would that look like as an integer? If I lose $7, what would that look like as an integer? Ellie? It would be a minus, so I'd have to put my dollar sign, because I'm talking about money, and then a -7. A -$7. What about if I find $9? What kind of a number would that be? Maddie? A +9.
9.
What if I take 8 steps forward? So if I put the number line on the floor, and I took 8 steps forward, would I be going towards the positive numbers, or would I be going towards the negative numbers?
It depends which way the number lands.
Well, if I'm going towards negative, I'm actually going backwards. Because shouldn't 0 be my starting point?
Yes.
Yeah.
So if I'm going to walk forward on that number line, I'm going to the number, whole number of 8. Correct. +8. Football. You gained 3 yards. Is that a positive or a -3? Positive. I'm on an elevator. And I'm going to ride the elevator down 5 floors. That would be a -5. I need you, do you see underneath where we just wrote the word opposites?
Yes.
Underline or circle it or box it in or highlight it. And write the definition for opposites in your notes. Underneath where you just wrote is the definition opposite, or is the word opposites. The definition of opposites. Numbers that are the same distance distance from 0 on a number line, but in opposite directions. Numbers that are the same number from 0 on a number line, but in opposite directions. Numbers that are the same distance from 0 on a number line, but are opposite directions. Opposite of 4 is -4. Both are 4 units from 0. One is positive, one is negative. Does anybody need more time? This part is not in your notes. I need you to help me answer these questions on the smartboard, please. Write a number to represent the temperature shown by the thermometer. What should be the number that I look at to help me figure out what's going on? If I'm going to pick up this thermometer, where should I probably center my attention to begin with? Say that louder, please.
0.
0. Why?
Because that's where the starting point would be.
That's the starting point of all number lines, right? Now I'm either going above 0 or I'm going below 0. In a regular thermostat, this would be red, correct? Have we reached 0 yet?
No.
So if we've not made it to 0, that's a definite sign that we have a negative value. When I start at 0, if I'm going to go down my tally marks, and they're probably a little hard for you to see. Does that help? Kind of? How far down have we gone from 0? So here's 0. How far down have we gone?
3 degrees.
3. We've gone to a -1, -2, -3 degrees Celsius. When you have to record temperature, make sure that that degree sign is super tiny, because that would be awfully easy to compare with or be easily confused with a -30. Next one. Seawater freezes at about 28 degrees Fahrenheit or about 2 degrees Celsius below 0. Write a number to represent the degrees, or write a number to represent the Celsius temperature. How would we do that? The question again, seawater freezes at 28 degrees Fahrenheit or about 2 degrees Celsius below 0. Write the temperature to represent Celsius degrees. What would that be? Zane?
0 degrees.
No. 2 degrees Celsius below 0. What would we do? -2 degrees Celsius. They wanted the Celsius temperature to be recorded. Back into your notes. 0 separates positive from negative. So it says you can graph positive and negative numbers on a number line. 0 is neither one. 0 separates the positive from the negative. It is not positive nor is it negative. It is the only number that does not have a positive or a negative. Okay? Because it's the separation point. On a number line, the further the number is to the left, the smaller it is. The further a number is to the right, the bigger a number is. For example, on the number line, which is bigger, -20 or -10?
-10.
Why is -10 bigger than -20?
It's closer to 0.
It's closer to 0. Would you rather lose $10 or lose $20? I would much rather lose $10 as well, because it's closer to 0 and I'd gain it back faster than gaining back 20, correct? Well, I'm with you, but we know how that's worked out for you in the past.
I'd rather gain money.
We've all lost money at some point in time.
I lost.
It happens all the time. All right, so number line, compare the numbers and order the numbers from least to greatest. When we graph these, we need to put a dot at each of those numbers on the number line, and we should also put them above the number line. The numbers below represent all the numbers on the number line. Graphing them is putting a dot on the number line and recording what they are above that number line. As we fill in our boxes, -3 is blank units to the left of 0. 3. -2 is blank units to the left of 0. And 2 is blank units to the right of 0. Below the number line, -3 is to the left of -2, and -2 is to the left of 2. So -3 is less than 2, which is, -3 is less than -2, which is less than +2. Those are in order from least to greatest when that's the case. As you look at the number line, which one's furthest to the left? Then, and then the biggest would be +2. So when you graph them on a number line, whatever's furthest to the left is actually the smallest value that you have. Questions on graphing integers? Graph 0, 2, and -6 on a number line and compare them. Now, in this question, that's just a basic number line, correct? If you're ever told to make a number line, it should look very, very similar to this. Notice that there's equal distance between all of our numbers, and they're going up by the same value every single time between those tally marks on that number line, correct? Graphing it is on the number line and written above. So, put a dot on 0 and write your 0 above. You have successfully graphed 0 then when you've done that. Do the same thing with 2. Put a dot, record the number 2 above, and do the same thing at -6. On a test or quiz, if you are asked to graph them on a number line, that will be required. Okay? Now, we are supposed to put the numbers from least to greatest. According to that number line, which one of those numbers is the smallest? In the middle?
0,
And the largest?
2.
Correct. -6, 0, 2. Fill in the blank with absolute value. Fill in the blank with the word absolute value. Absolute value is the number's distance from 0 on a number line. Absolute value will always be positive. Distance can't be negative. Your distance from 0 is always positive. For example, what is the absolute value of -3? In other words, how far is -3 from 0?
3.
It is 3 units away. Using the number line. Use the number line to find the absolute -5 and the absolute value of +5. Notice on the number line they've circled -5. How many units from 0 is that? 5. They've also circled a +5. How far from 0 is that? 5. Notice they are both 5 units away from 0. So, what is the absolute value of -5? How far away from 0 is it? 5 units. What is the absolute value of +5? How far from 0 is it? It's 5 units away. Notice both of them are positive answers. Any questions? If you came across this, how would you read that correctly to yourself? Ellie,
Absolute value of -10.
read the whole thing, left to right.
Write the absolute value
That was perfect. When you come across these brackets on either side of -10, you say absolute value of, and in this case, -10. So in words, that would be the absolute value of -10. We are supposed to then solve the absolute value of -10. How far away from 0 is -10, everybody?
10.
My answer would simply be 10. Help me solve these 3 questions. They're not in your notes, just help me solve them. Simplify each expression. The absolute value of 17 is absolute value of -5,
5.
and the absolute value of -7.
7.
Correct. Last questions. Describe a quantity each integer could represent. Now, you are doing the opposite. Now I've given you an integer. You tell me something in real life that could represent -23. Bodie.
Losing 23 of my 50 pairs of shoes.
Losing 23 pairs of shoes. Yikes. What else? Ellie. Okay, so you purchased $23 worth, so now you have $23 less in your checking account. Okay. Taylor.
23 flowers died
23 flowers died
in the garden.
in your garden. Okay. So you lost 23 flowers then. Zane?
Minus 23 yards.
Lose 23 yards in football.
That's
Yikes.
No.
It could happen.
That's painful.
It could happen, right? They're rushing the quarterback. He gets tackled behind the line of scrimmage. You could have a loss of 23 yards. You're probably kicking off on that down, right? Okay. Any others? January's right around the corner, and we live in Minnesota.
Minus 23 degrees.
What?
Minus 23 degrees.
20? Yeah, -23 degrees Fahrenheit outside. It's
Sun.
not too far away. Pick one of those scenarios and record it into your notes. Pick a similar scenario or one of those and record that into your notes. Positive 120. What might a positive 120 represent? Tina.
Finding $120.
Found $120.
I was just gonna say you worked.
You know what? I had something similar to that happen to me once. I actually went to an ATM to get some money out, and someone must have withdrawn money and not taken all of it. So there was $80 sitting in the ATM yet.
Sure.
I did.
I went to it, so.
I would have
How do you return that to
Yeah, I
the
suppose.
the lost and found?
Yeah, I suppose you never know because you could go up and ask them, do you know whose this is? And they could just easily pocket it themselves.
Right.
Or like,
You can give it to the police because they'll say it's evidence and they'll just take it.
I don't know what would happen. I
yeah.
kept it. I don't know if it was the right thing to do or not. But yes, you find that is $20.
Lucky
Okay, we need more examples. Taylor.
Winning a bag of 120
Okay, so winning a bag of 120 gummy bears. Good. Zane.
And I think it was $120. One time when I was at the fair, I found a wallet sitting on one of the rides with $120 in it. And I was like, no, I said we shouldn't keep it. We should give it to someone or something, like the cops. I was really dumb and I gave it to a carny, so he just most likely pocketed the money.
Yeah. Most of the
It's
time.
hard to say, you know, there's honest people out there, and sometimes the people we least expected, so hopefully they did the right thing.
Yeah.
How about you win 120 points, or you have 120 points in a game? Could basketball be 120 points? Happens all the time in the NBA, right?
Yeah.
That one team has 120 points. Okay, record something for 120 in your notes. Finally, -12. What could -12 be, Ethan?
Losing 12 of really anything.
Losing 12 of something. How about golf?
talked about
Great.
this before, and
Good.
you said there's like a par or something.
In golf, every course has par. So if I go up to hole number 1, it's going to tell me that it's a par 4 hole, which means when I get up there, it should take me 4 strokes of my club to get from the beginning to the end and getting my ball in the hole. So if I go out to, say, Pine Ridge Golf Course, out by between Brandon and Evansville, right? Let's say that that course is a par 80 course.
80?
So if it's a par 80 course to golf 9 holes, it should take me 80 strokes to go all the way from the beginning of the course to the end of the course. So what do you suppose negative 12 means?
When you get less.
It's a par 80 course. So what would negative 12 be, Destiny? Not 92, actually.
No, it's actually should end with 8. Wait, no. If it's 80.
It means you're
Oh,
12
yeah, 60.
strokes under 80.
Oh.
So you actually golfed it in how many?
112.
That means you golfed it in 68 strokes. So if you are in negative 12, you are 12 strokes under whatever par was. Okay, pick a scenario for negative 12. That should be the end of our notes, correct?